Good morning, all of you. In this session, I am going to explain about how to locate centroid or center of gravity of an T section and I section. Okay. In this class, I will explain how to determine or how to calculate centroid or center of gravity of an T section and I section. Okay. Now, these are the important fundamentals. Here, the centroid of an rectangle or square. Here, CG is the centroid or center of gravity of an rectangle or a square. Okay, here capital B is the base of the rectangle, capital D is the depth of the rectangle. Okay, this is the position of centroid or center of gravity. Okay, half of the base and half of the depth. Now, locate the centroid or center of gravity of the given T section. Okay, here this is the given figure. You have to locate the centroid or center of gravity of the T section. Okay, here the total width of the rectangle width of the top rectangle is 100 mm, and the depth of the entire section is 80 mm, and here the width of this bottom rectangle is 20 mm. Okay, now first of all, you have to split up this given section into two rectangles. Okay, first of all, you have to split up the given T section into two rectangles. First one is vertical rectangle and second one is horizontal rectangle. Okay, this is a top rectangle, this one is bottom rectangle. Okay, now so let's consider this bottom vertical rectangle as section 1. Okay, this top rectangle as section 2. Okay, now B1 is the base of the bottom rectangle, B1 equal 20 mm, and D1 is the depth of the bottom rectangle. Here you can observe B1 equal to 20 mm and D1 equal to depth of the bottom rectangle, D1 equal to 60 mm, and B2 is the base of the top rectangle and D2 is the depth of the top rectangle. Okay, so here the given T section is symmetric about y-axis. Okay, symmetric about y-axis. So the centroid of an T section always lies on y-axis. Okay, lies on this symmetric axis. Okay, this is a reference x-axis and this is a reference y-axis. Okay, A1 is the area of the bottom rectangle, A2 is the area of the top rectangle. Okay, the given T section is symmetric about y-axis, hence the centroid lies on symmetric y-axis only. Okay, the values of x are 0. Okay, because this given section symmetric about y-axis, therefore the x values are 0. Okay, A1 is the area of the bottom rectangle, A1 equal to base B1 and depth D1, B1 into D1 equal to 20 into 60 equal to 1200 mm square, and area 2 is the area of the top rectangle, A2 equal to base 2 into depth 2. Okay, B2 equal to 100 mm and D2 equal to 20 mm. Okay, now 100 into 20 equal to 2000 mm square is the area of a top rectangle. Okay, now I am drawing the diagonal lines to locate the centroid. Okay. So this intersecting point is the position of centroid. Okay. And here, sorry, now I am drawing the diagonals for a bottom rectangle. This intersection point is the centroid of a bottom rectangle. Okay. C1 and C2. Okay, here C1 is the centroid of a bottom rectangle. C2 is the centroid of a top rectangle. Okay. So C1, C2 are the individual centroids. Okay. Now C1, here Y1 is the distance of a centroid C1 from x-axis. Okay. Y1 is the distance of centroid C1 from x-axis. Already we know that the centroid of a rectangle always lies at half of the depth. So d1 by 2. Y1 equal to d1 by 2. Here d1 equal to 60. So y1 equal to 30 mm. In similar way, y2 is the distance of a centroid C2 from x-axis. Okay, y2 is the distance of centroid C2 from x-axis. Okay, so here y2 equal to depth of a bottom rectangle d1 plus half of the depth of a top rectangle. Okay, d1 plus d2 by 2. Here, this given T section is symmetric about y-axis. So x1 and x2 0. x1 equal to 0, x2 equal to 0. Okay. Y1 equal to d1 by 2 equal to 60 by 2. d1 equal to 60. So 60 by 2 equal to 30 mm. And y2 equal to d1 plus d2 by 2. Okay. d1 equal to 60 mm plus 20 by 2. Okay. 60 plus 20 by 2 equal to 70 mm. Okay. Now x2 equal to 0. Okay. Now, here section 1 is bottom rectangle, section 2 is top horizontal rectangle. Okay, B1, D1, B2, D2 are the dimensions. A1, A2 are the individual areas. X1 equal to 0, X2 equal to 0. Okay, Y1 equal to 30 mm, Y2 equal to 70 mm. Okay, already we know that XC equal to A1 X1 plus A2 X2 by A1 plus A2. Here XC is the distance of centroid or center of gravity of an entire section from YY axis. Okay. In similar way, here X1 X2 both are zeros. So XC also 0. In similar way, YC equal to A1 Y1 plus A2 Y2 by A1 plus A2. Okay, now you have to substitute the value of A1, A2, Y1, Y2. Okay, after substituting these values, you can get the value of YC. YC equal to 35. YC is the distance of a centroid or center of gravity from XX axis. Okay, so this is the XC and YC are the coordinates of the centroid or center of gravity. Okay, now I am showing the position of centroid or center of gravity. Now here you can observe C1 is the centroid of a bottom rectangle, C2 is the centroid of a top rectangle. Okay, so C1 and C2 are the individual centroids, but CZ is the centroid of an entire T section. Okay, CZ is the centroid of an entire T section. Already we know the value of XC and YC. XC equal to 0 and YC equal to 35 mm. Okay. So the YC is the distance of centroid or center of gravity from XX axis. Okay. So this is the position of centroid or center of gravity of an entire T section. Okay. Now coming to the another example problem. Locate the centroid or center of gravity of the T section, inverted T section. Okay. So these are the dimensions. Now, first of all, we have to split up this given T section into two rectangles. Okay. This is a bottom rectangle. Now this one is here B1, base B1 equal to 100 mm. and D1 depth D1 equal to 20 mm. Okay, so D1 and B1 are the dimensions of a bottom rectangle. Now I am considering this vertical rectangle as a section 2. Okay, now here base 2 equal to 20 mm and depth 2 D2 equal to 60 mm. Okay, so these all are the individual dimensions. Okay, here first of all you have to split up this given T section into two rectangles. Okay, bottom rectangle and vertical rectangle. After that, now you have to consider a reference x-axis and y-axis. Okay, here the given T section also symmetric about vertical axis. Okay, so this given inverted T section also symmetric about y-axis. So the centroid of an T section lies on y-axis. Okay, so the values of x1 x2 both are 0. Okay, so here A1 is the area of a bottom rectangle, A2 is the area of a top rectangle. Here B1 equal to 100 mm, D1 equal to 20. So 100 by 20 equal to 2000 mm square is the area of a bottom rectangle. And A2 is the area of a top rectangle, that is 20 and 60. 20 by 60 equal to 1200 mm square. Okay. Now I am drawing the diagonal lines for locating the centroid of a bottom rectangle. Okay, this intersecting point is centroid of a bottom rectangle C1. Okay, C1 is the centroid of a bottom rectangle. Now x1, here x1 equal to 0 and y1 equal to half of the depth. Okay, y1 is the distance of centroid C1 from x-axis. Okay, y1 equal to d1 by 2, d1 equal to 20, 20 by 2 equal to 10 mm. So y1 equal to 10 mm. Okay, now for locating the centroid of a top rectangle, you have to draw diagonal lines. Okay, now I am drawing the diagonal lines to locate the centroid of a top rectangle. Let C2 is the centroid of a vertical rectangle. Okay, now here you can observe C1, C2 are the individual centroids. Okay, C1 and C2 are the individual centroids. Okay, whereas CZ is the centroid or center of gravity of an entire section. Okay, so here y1 equal to d1 by 2. Now y2 is the distance of centroid C2 from x-axis. Okay, y2 is the distance of a centroid C2 from x-axis. Okay, y2 equal to depth of a bottom rectangle plus half of the depth of a top rectangle. Okay, d1 plus d2 by 2. Okay, now here x1 equal to 0 and x2 equal to 0 because this given T section is symmetric about y-axis. So x1 equal to 0 and x2 equal to 0. Okay, y1 equal to d1 by 2. So that value equal to 20 by 2 equal to 10 mm. And y2 equal to d1 plus d2 by 2 equal to 20 plus 30 equal to 50 mm. Okay, now section 1 is bottom rectangle, section 2 is top vertical rectangle. These are the individual dimensions. A1, A2 are the individual areas. A1 is the area of a bottom rectangle. A2 is the area of a top rectangle. Okay, x1 equal to 0, x2 equal to 0 because the given T section is symmetric about y-axis. So x1 and x2 values are 0. y1 equal to half of the depth of a bottom rectangle. y2 equal to depth of a bottom rectangle plus half of the depth of a vertical rectangle. Okay, so y1 equal to 10 mm, y2 equal to 50 mm. Now already we know the formula for xc. xc is the position, xc is the distance of centroid or center of gravity from y axis. Okay, xc equal to a1 x1 plus a2 x2 by a1 plus a2. Here already we know that x1 and x2 values are here, x1 and x2 values are 0. So the value of xc equal to 0. Okay, In similar way, yc equal to a1 y1 plus a2 y2 by a1 plus a2. Yc is the distance of centroid or center of gravity of an entire section from xx axis. Okay, now here a1 equal to 2000, a2 equal to 1200, and y1 equal to 10 mm, y2 equal to 50 mm. Now you have to substitute these values in this equation. After substituting these values, you can get the value of yc. Yc equal to 25 mm. Okay, so here xc equal to 0, yc equal to 0. Okay, xc is the distance of centroid from x-axis, sorry, from y-axis. Okay, distance of centroid from y-axis equal to 0. Distance of centroid from x-axis equal to 25 mm. Okay, now I am showing the position of centroid for inverted T section. Here CG is the position of a centroid. Okay, C1 is the centroid of a bottom rectangle. C2 is the centroid of a top rectangle. Okay, C1 and C2 are the individual centroids, but CG is the centroid of an entire T section. Okay, CG is the centroid of an entire section. C1 and C2 are the individual centroids. Okay, centroid or center of gravity is a point at which the whole area of the body is assumed to be concentrated. Okay, now already we know that yc equal to distance of centroid from x-axis, that value equal to 25 mm. Okay, this is the position of centroid for inverted T section. Okay, so here xc equal to 0 because this centroid lies on y-axis, therefore x value is 0. Okay, now coming to the another example, look at the centroid or center of gravity of the given I section. Okay, this is a given figure. So here the base of a bottom rectangle is 100 mm and height is 20 mm, and the base of a web is 20 mm, and the base of a top flange is 120 mm, and the total height is 90 mm. Okay, yeah, this one is the top flange, this one is web, this one is bottom flange. Okay, this is top flange, this one is web. Okay, this one is bottom flange. First of all, you have to split the given I section into 3 rectangles. Bottom rectangle as a bottom flange, web and top flange. Okay, first of all, you have to split up this given I section into 3 rectangles. Okay, bottom flange, web and top flange. Okay, yeah, this is, now I am considering this bottom flange as a section 1. The dimensions of a bottom flange or B1 equal to 100 mm and D1 equal to 20 mm. Okay, these are the dimensions of a bottom flange. Now this is the web. I consider this web as a section 2. Okay, now this is the depth D2 equal to 60 mm. Okay, 90 minus 20 minus 10. Okay, 90 minus 30 equal to 60 mm. Okay, that is the depth of the web, and base of a web equal to 20 mm. Okay, B2 equal to 20 mm. Okay, from here to here, base B2 equal to 20 mm. Now I am considering this top flange as a third section. The base of a top flange, sorry, depth of a bottom flange, depth of a top flange D3 equal to 10 mm, and base of a top flange B3 equal to 120 mm. Okay, now I am considering the reference x-axis. Okay, Now this is the reference y-axis. The given I section is symmetric about y-axis. You can observe. Okay, this given I section is symmetric about y-axis. Okay, so therefore the centroid of an entire I section lies on y-axis. Okay, that means the values of x1, x2, x3 are 0 because the given section is symmetric about y-axis. Okay, so this is y-axis, this is x-axis, this is the origin, bottom rectangle, web, top flange. Okay, so here b1, a1 is the area of a bottom rectangle. A1 equal to b1 d1, b1 equal to 100 mm, d1 equal to 20. So 100 by 20 equal to 2000 mm square. And a2 equal to area of a web. Okay, a2 equal to base 2 into depth 2, that is 20 into 60 is the area of a web. And a3 is the area of a top flange, b3 into d3, 120 into 10 equal to a3. Okay, now I am drawing the diagonal lines. Now I am drawing the diagonal lines for locating the centroid of a bottom rectangle. Okay, so this intersecting point is the centroid of a bottom rectangle. Okay, let C1 is the centroid of a bottom rectangle. Okay, so here y1 is the distance of centroid C1 from x-axis. Okay, so already we know that centroid of a rectangle always lies at half of the base and half of the height. Okay, so y1 equal to half of the depth, so d1 by 2, y1 equal to d1 by 2. Okay, d1 equal to 20 by 2 equal to 10 mm. Okay, y1 equal to 10 mm. In similar way, I am drawing the diagonal lines for web for locating the centroid of a web. Let C2 is the centroid of a web. Okay, this intersecting point is the centroid of a rectangle. Let C2 is the centroid of a web. Okay, now y2 is the distance of centroid C2 from x-axis. Okay, y2 is this distance of centroid C2 from x-axis. Okay, y2 equal to depth of a bottom rectangle plus half of the depth of a web. Okay, d1 plus d2 by 2. Okay, now repeat same procedure for top flange. Okay, now I am drawing the diagonal lines for locating the centroid of a top flange. This intersecting point is the centroid of a top flange. Let C3 is the centroid of a top flange. Okay, now y3 is the distance of centroid C3 from x axis. Okay, y3 is the distance of centroid from x axis. Okay, now you can observe the given I section is symmetric about y axis. Therefore, the values of x1, x2, x3 are 0. Okay, here a1 equal to 2000 mm square, b1 into d1, a1 equal to b1 d1 equal to 100 by 20 equal to 2000 mm square, and a2 equal to base 2 into depth d2. Okay, area of a web, that value equal 20 by 60 equal to 1200 mm square. And a3 is the area of a top flange. Okay, a3 equal to base 3 into depth d3, that is 120 by 10 equal to 1200 mm square. Okay, a1, a2, a3 are the individual areas. Okay, capital A equal to a1 plus a2 plus a3 is the total area of a I section. Okay, now the given I section is symmetric about y axis, hence the centroid lies on symmetric y axis. The values of x are 0. Okay, x1 equal 0, x2 equal 0, x3 equal 0, because the given I section is symmetric about y axis. Okay, so the centroid of an I section always lies on symmetric axis. Now y1 equal to d1 by 2, that value equal to 20 by 2 equal to 10 mm. Okay, d1 equal to 20 by 2 equal to 10 mm. Now y2 equal to d1 plus d2 by 2. Okay, d1 equal to 20 plus d2 equal to d2 equal to 60 by 2. d2 by 2 equal to 30. That value y2 equal to 50 mm. In similar way, y3 equal to depth of a bottom rectangle plus depth of a web plus half of the depth of a top flange. Okay, y3 equal to d1 plus d2 plus d3 by 2. Okay, d1 equal to 20 plus d2 equal to 60 plus d3 equal to 10 by 2. Okay, d3 by 2 equal to 5. Okay, 20 plus 60 plus 5 equal to 85 mm. Okay, here I consider bottom rectangle as a section 1, middle web as a section 2, top of flange as a section 3. Okay, a1 here, a1, a2, a3 are the individual centroids, and these all are the individual dimensions. Okay, x1, x2, x3. Okay, these three values are 0 because the given I section is symmetric about y axis. Okay, y1 equal to d1 by 2 equal to 10 mm, y2 equal to d1 plus d2 by 2 equal to 50 mm, y3 equal to d1 plus d2 plus d3 by 2 equal to 85 mm. Okay, these all are the distance of a centroid from x axis. Okay, now xc is this distance of centroid of an entire I section from y axis. Okay, here x1, x2, x3. Okay, x1 equal to 0, x2 equal to 0, x3 equal to 0. So therefore xc equal to 0. Okay, xc equal to 0. That means the distance of centroid from y axis is 0. And similarly yc equal to a1 plus a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Here yc is the distance of centroid of an entire I section from x axis. Okay, now you have to substitute the value of a1, a2, a3 and y1, y2, y3. After substituting these values, you can get the value of yc. yc equal to 41.36 mm. Okay, yc equal to 41.36 mm. Okay, yc is the distance of centroid of an entire I section from x axis. Okay, now I am showing the position of a centroid of an entire I section. This is a bottom flange. Okay, now this is a web. Now this is a top flange. Okay, this is a reference x-axis. This is a symmetric y-axis. Okay, so here this intersecting point is the centroid of a bottom rectangle C1, and this intersecting point is the centroid of a web, that is a C2. Now C3 is the centroid of a top flange. Okay, C1, C2, C3. These all are C1, C2, C3 are the individual centroids. C1, C2, C3 are the individual centroids. Whereas CZ is the centroid or center of gravity of an entire I section. Okay, so YC is the position of a centroid from x axis. Okay, YC is the distance of centroid or center of gravity of an entire I section from x axis. Okay, from calculations yc equal to 41.3 mm. Okay, this is the position of a centroid of an entire I section. Okay, xc equal to 0 because the given centroid the centroid or center of gravity of an I section lies on y axis. Okay, so this is the final answer for this I section. Okay, in next class I will explain how to locate the centroid or center of gravity of an C section and U section. Okay, in next class I will explain how to locate centroid or center of gravity of an C section, U section. Okay, I will explain about these three problems. Okay, in next session, I will explain about these three problems. Okay, friends.